It's 3 a.m. Your phone vibrates. It's a PagerDuty alert. The auto service is failing. You check the logs, but the auto service is actually fine. The real problem is the inventory service. A developer changed a shared data contract in a core repository. Now the checkout process is broken. You are deep in a jagged trace. You want to know why a simple checkout needs 7 network hops. All this to calculate the sales tax. We have all been there. You were promised independent scaling. You were promised developer velocity. What you actually got was a distributed monolith. It has the worst properties of both worlds. Your cloud bill looks like the GDP of a small nation. Your mental health is at an all-time low. This is the reality of the modern architecture. We build systems for millions of users when we only have hundreds. My name is Sergio, and I spend too much time thinking about why we make our lives harder. We chase scalability that we never actually reach. If you are tired of managing 50 YAML files for a Hello World service, hit on subscribe. Give this a thumbs up if you find this helpful. Let's be honest for a second. We are not Google. We are not Netflix. Your CRUD application with 500 users does not need a service mesh. It needs a focused team on a simple code base. Here is the thing. Most people are wrong about microservices. We treat them like a trophy. We think they prove we are a real tech company. In reality, microservices are attacks. You trade code complexity for the operational complexity. In a monolith, your enemy is a messy code. You can fix a messy code with a refactor. In microservices, the enemy is the network. The network is a bad enemy. It is slow. It is unreliable. It breaks in ways you cannot test easily. We were told microservices decouple teams. But if service A fails when service B is down, they are not decoupled. They are just far apart. They are tied together by a wire and a lot of latency. Let's look at a task. We want to process an order. In a monolith, you use a database transaction. It is simple. It follows the ACID rules. If the update fails, everything rolls back. You do not get partial data. You do not get ghost orders. The code is easy to read. It is easy to test. Now let's look at the modern way in microservices. Every service has its own database. You cannot use a simple transaction. You have to use the Saga Pattern. You have to manage the state manually across multiple network calls. Let's look at this mess. We replaced 5 lines of logic with a manual state machine. You have to write undo logic for every single step. What happens if the release call fails during a rollback? You get data corruption. You will fix it manually with SQL scripts on Monday morning. This is not resilience. This is just moving the problem from the compiler to the network. And don't get me started with eventual consistency. This is just a fancy way of saying the data will be wrong for a while and we hope it fixes itself. Why do we do this? Let's be realistic. It's rarely about technical needs. It's often resume-driven development. You do not get a senior role at a big company by saying you built a clean monolith. You get the job by saying you migrated to a multi-region, event-driven architecture. You talk about Kafka, Kubernetes, and Istio. These words make sound you expensive, so you built a complex system to justify your salary. We also call for the sunk cost fallacy. Your team spends 6 months setting up a CI/CD pipeline for 20 services. It is slow, it is hard to use, but you cannot admit it was a mistake. You have invested too much time, so you add more observability tools to hide the mess. You spend more time fixing the pipeline than writing features. Then there is the cargo cult behavior. You saw a blog post about how Spotify or Netflix does things. You think you need to copy them, but Spotify has thousands of engineers. You have 10. They have problems you will never have. Copying their architecture is like buying a semi-truck to get to the grocery store. I know what you are typing in the comments right now. But Sergio, our monolith is a nightmare. The build takes 45 minutes. No one understands the bidding module. Look, if you cannot write clean code in one repository, you cannot write in 20. If your monolith is a big ball of mud, microservices will be a distributed big ball of mud. You have just added network lag to your bytecode. Your problems are not architectural. Your problems are discipline and boundaries. But we need to scale the image processing service independently. Are you actually scaling it? Or are you just running 3 pods instead of 2? Most scaling needs are solved by a better database or more RAM. Vertical scaling is cheaper than a developer time. If one part of your app is a truly bottleneck, extract only that part. You do not need to explode the entire application into millions of pieces. What should you actually do on Monday morning? Audit your bounded context. If you change 3 services for a single feature, your boundaries are wrong. This is tag coupling. Merge those systems back together. It is okay to delete services. It is a sign of intelligence. The Monolith first rule: start with a monolith, but use a strict internal modules. Use tools to prevent module A from calling modules B private function. If you can't keep your modules clean in one repo, you are not ready for microservices. The rule of 3: do not extract a service unless you have 3 solid reasons. It sounds cool, it's not a reason. I want to use Go instead of Python, it's usually a mistake. Extract for deployment speed, heavy resources needs, or different security levels. Fix your build. Invest in a faster CI/CD. Often, the monolith is not the problem. The poor build system is the problem. Parallelize your tests. Clean up your dependencies. Measure the overhead. How much time does your team spend on plumbing? If you spend more than 30% of your time on IAM roles, service discovery, or deployment YAMLs, you are overgenerate. Stop, simplify. The goal of a software engineer is to ship value to the users. The goal is not to have the most complex system on GitHub. Stop chasing trends designed for companies with 10,000 engineers. Fix your code so you actually enjoy your weekend, and see you in the next video. Bye!